Okay, so here we are back in the terminal. I've cleared the screen. There's a couple more things we need to do. You can see I'm still in the Figaro environment, so I need to deactivate that. And then activate my Qiime environment. Okay. And then the Qiime2 script in the download that you got is not executable. It's in white on my screen, and if you look over here, it's readable and writable by the user and readable by group and world, but it's not executable. So we need to change that. One way to do it is chmod u+x, and then the file name. And then if we list it again, we see it's in green, and there's an X here for user. So now we can execute it. But there's one other thing I want to do. I don't want to, if you execute it now, it will run to completion. I don't want to do that. I want to execute one part at a time so I can explain what's going on with each step. Okay, so if I open the file in Notepad++, we will run the first two parts here, and that will import all the sequences into a special Qiime2 format, and then it will produce a visualization file which we can examine in Qiime2 view. But I want to comment out all the rest of the script right now so that it doesn't run. I can select it, select block comment, and it inserts comment characters at the beginning of each line so they won't run now. I will save this, go back to my terminal. Now if I examine the Qiime script, we see the first part will run and the rest are commented out. So to start running, I have to tell the computer where it is, /Qiime, and we're off and running. This takes a couple of minutes. Okay, so it's imported this sequences and it's created this paired in demux.qza file. So that's a compressed format holding all of the sequence data. So here we have the files. We can see the demux.qzv is a visualization file. I want to load that into Qiime2 view, so you can search for it in Google like this. Click here. Then you can just drag and drop that file over like that, and you will get a display of the sequence data, how many forward reads there are on minimum number, average number, total. Some bar plots about the number of samples that have different numbers of sequences in them. They're all pretty uniform because I sampled to approximately 10,000 sequences per sample. You can download this as a tab delimited file if you want to. Okay, so let's go back to the script file. We can comment out that part. We don't need to run it again. And then the next part is to run data2. So this is the heavy lifting part of the script. So this part's going to run data2. We have our truncation parameters in here. We're going to use pooling method equals sudo. So by default, data2 runs one sample at a time, and it discards singleton sequences. By running one sample at a time, it's faster, and the time it takes is linear with the number of samples. But it discards singletons in each sample. So the pseudo pooling keeps track of the sequences that occur as singletons in each sample. And after it finishes, it goes back and looks to see if any of those occurred in more than one sample. And if it did, then it retains those sequences. And then Qiime method is pooled. We're going to look at all of the data pooled to determine whether sequences are chimeric or not. This is a number of threads. I have 8 threads on my computer. I don't want to use all of them, so I set that to 6. So it's going to produce an OTU table, or ASV table in this case. It's going to produce representative sequences, one sequence for each taxa in the OTU table, and it's going to produce some denoising stats that we will look at with Qiime view. So let's save this, go back to our terminal, and run again. Okay, so the .2 part is finished running, and right now it's creating that visualization file. And it's done. So now we can go back and look at the visualization file. I will have to go back to get the Dropbox here, and then we can refresh this view and drag denoising stats over there. And I will maximize this so we can see a little better. So this gives for each sample the number of input reads, the number after filtering, which is based on the truncation parameters we gave, the percentage that passed that filter, the number that passed denoising, the .2 correcting sequences, the number that was successfully merged, so we're merging our forward and reverse reads to produce just the amplicon part, the percentage of input that were merged, the number that were non-chimeric after merging, and the overall retention. So this is actually pretty good. Most of them are over 80%. So we have good retention overall. So now we'll go back to our Qiime2 script. We can comment out what just ran. The next part is to align the sequences and produce trees of the sequences. So I will comment out that. I will uncomment that. Save it. Go back to our terminal and run again. So that didn't take very long. I can list the contents right here, and we can see the files that have been produced so far. Here's the aligned representative sequences, and the rooted tree and the unrooted tree. So let's go back to the Qiime script. We will comment that out so it won't run again. The next part is to export what's been produced by Qiime into formats that can be read into R easily. I like to do all of my analysis in R, and so I will uncomment this part. And what's going to happen is it's going to export the OTU table to a directory fileseek, a subdirectory fileseek. It'll export that as a biome file. It'll also convert it to just a flat tab separated value file. These two lines modify that a little bit so that it's more easily read into R. And then it's going to export the representative sequences as FASTA sequences and export the tree files named unrooted tree and rooted tree. So we'll save this and run it again. Okay, so that finished. It didn't take very long. It's just exporting things. We'll go back to the Qiime script, and we can comment out that part. Okay, the last part to do is to classify the representative sequences. There's several ways of doing this, and this particular block here was to download a classifier from the Qiime2 site, and it's for the V4 region, and it was built using Green Genes 2 sequences. So this is a version of Green Genes that was just released in 2022. I was not able to run this on my notebook. It got killed for some reason. It did run on the cluster at MSU just fine, but it gets killed on my notebook. So I can't do that here. What we will do instead is to use vsearch. So I will uncomment this. It uses a database that is included in your download. And it will, this is the thing about Qiime2. vsearch is included in Qiime2. We don't need to use a Qiime2 plugin to run it. We can run it directly, so to speak, like this. So we'll use vsearch, and the command is --syntax is the classifier. It's going to classify the DNA sequences.fasta file. It's going to use that database that is included in your download, and it's going to write the results to gt2 syntax classified.tsv. And we'll be able to import this into R very easily. So save that, go back to our terminal, and run again. Okay, that's very fast, and that's one reason I like to use syntax. It's not a Bayesian classifier, but it does produce results very comparable to the RDP classifier. There's also a Bayesian classifier you can use with Qiime2. So if I list the contents of this directory now, we see we now have this fileseek directory, and if I list the contents of fileseek, we see we have the representative sequences, we have the classification table, an OTU table, and a rooted tree. The only thing we don't have is the sample data table, which is still in the tutorial Cosich directory. We can see it right here. So we can copy that down to fileseek. And then if we list what's in fileseek, we have the sample data table too. And so now we're ready to use R and to use these files to create an experiment level fileseek object.